Okay, welcome back to the CanJS Community Hangouts. This week we're focusing mainly on forms and building web forms and different cool things you can do with web applications and forms. But before we actually dive into our forms, Dan Connor from Dan Connor Consulting is going to give a presentation on an API middleware plugin he's made. And I'll let him tell you about himself and his consulting company in just a second. And then right after he finishes with that presentation, which should be about 7 minutes, we're going to move on to Alexis, who will give a presentation on show and hide helpers for can.stache. And then on to Mihael, who's going to show us a can form plugin, which is like a can component plugin that he's been working on and releasing. So, and then the last thing is, both on the event page and in the chat here, we have a link where you can go and sign up to our email list, where we can send updates every week that we're with the latest links and where to find these. You can also do it on Google+, and we'll have a blog post later today too that'll actually have a Google Calendar that you can subscribe to and find all of our events there as well. So, without further ado, Dan, thanks a lot for joining us. He's our guest speaker, and we're really happy to have him here. And I'll turn it over to you.
Hi guys, I'm Dan Connor. I'm a freelance web developer in New York City. I've been using the Bitovi Jupyter suite of products for a while. I've been using JavaScript MVC since like 2010, and more recently CanJS, with various clients that I work with, mostly working with small startup companies to build prototypes and to kind of renovate their products that are built old school with a bunch of jQuery spaghetti code into kind of maintainable MVC applications with CanJS and other technologies. So what I'm going to be talking about today is something that I built called ApePI. That's APEPI. And that stems from a challenge that I've experienced with highly observable systems like CanJS, wherein there's a common pattern where you have a lot of disparate controls on the DOM at the same time, monitoring some sort of common state. So you've got, the quintessential example that I experienced was an analytics dashboard where you have a lot of different controls. You want to keep them all fairly ignorant of each other. They're kind of requesting their own data and their own little silos, working in the MVC architecture. So these are all controls talking to models and sharing maybe a can map for their shared state. So what I encountered a lot was you would have a set of controls, whiteboard.
I love the whiteboard.
I didn't want to prepare slides and all this stuff. So anyway, you have like control 1, control 2, control 3. Oh, it's mirrored. Anyway.
It actually shows up fine for us. That's the crazy thing. It mirrors it for you, but for us it looks fine. Yeah, you don't have to write backwards.
That's good. Okay, so you have these controls. They're talking to a shared state. And they're bootstrapping their life cycle. When they boot up, they make a request to the API. So over here you have an API. So they create, there's some sort of master control that hands the state to these controls. So you can assume they all have the same state. And they make requests and they start influencing the state. And then the state, creates events. And these controls request their data from the API, each in their own individual kind of way. And then they get responses back. And because this is all asynchronous, you don't know what order of operations this is going to come back in. And often what happens when these controls get the responses back from the API, they're going to be modifying the state based on the information that they got back. Something about their world has changed, and they want to make the state current based on their understanding of the world. So maybe this is a date picker, and this is a some sort of graph, and this is maybe a category selector. And I actually built a little scaffold application based on that kind of principle of an analytics dashboard, and a link that I've shared here that I can screen share. But basically, they're doing this kind of tug of war on the state and modifying the state. And every time that state changes, it triggers new requests to the API. So there are kind of two problems here. One is you've got a lot of busyness on the state and a lot of events changing spontaneously. And the second problem is because these controls are all kind of ignorant of each other, and they should be, often a lot of these controls are actually requesting the same data, literally the same API routes with the same parameters. And you want to keep them kind of ignorant of each other. You don't want to have to manage that relationship. So what ApePI does is it does two things, basically. It does, well, three things. It does denormalization of requests. Deduplication of requests. So it's aware if there's a request out already for some bit of data that it doesn't have to make a second request. It basically adds additional requests onto a queue and then returns the data back to the controls that requested them. So if there's already one control that's requested maybe some analytics about video plays, and there's another control that's requesting that exact same analytics data, it queues those up using promises and then returns the data to both of those controls when the promise has been resolved. The second thing it does is it can do debouncing. So when that state is changing really rapidly, it can wait until the state has stabilized. It's got a little state machine inside of it. So it can wait until the state is stabilized before firing off those queries. And then the third thing it does, you can use holds. So you can, this is kind of like the API equivalent of can.batch start and stop, where you can say, I want my API layer to pause for a moment. I know I'm going to be destabilizing the state a lot. So I'm going to pause it, and I want the API to be quiet for a while, and then I can resume it once I know, it's perfect for like if you're initializing a lot of things in a new control view. So those are the basic principles of it. It integrates with CanJS pretty well. Basically what you have to do is in your model layer, swap out find one and find all, and the get queries there, and replace those with kind of the API middleware, and then you basically hand the API middleware can.ajax or jQuery.ajax, and it uses that backend and retains the API signature, so it's fairly transparent, and it just queues those up with promises. I can show you a little screen share of the application that I built to demo this. All right, can you see lane noisy analytics dashboard?
Yeah.
All right, so I've got the oops. Oh. All right. So I've got the debugging output on, so you'll see a lot of stuff getting spit out in the console, but my screen is not terribly large, so I'll try to make that fit. So what we have here is basically each of these boxes represents a control. It's a CanJS control, and you've got some plays viewers, and in an analytics dashboard, these would maybe represent a graph. So each of these is a graph. And you've got a category picker. When you change this, it's going to modify the state and trigger some queries. When you change the day of the month, it's going to modify the state and trigger some queries. And then you can see a JSON representation of the shared state that is shared between all of these things. So if, for example, this was a super noisy analytics dashboard and there were a lot of controls and they had to manage each other's state, and let's say you were doing something that was triggering a lot of rapid changes, like I'm going to simulate that right now by basically just changing this number really rapidly back and forth between 3 and 34 by pressing 4 and delete. And you'll be able to see down here in this console that it's going to debounce those requests and deduplicate those requests. So I'm just going to do that, kind of bounce.
Dan, are you still talking?
Yes.
Oh, okay. I thought you went dead for a second and it kind of like faded out. I was just making sure.
All right. Sorry. So you can see kind of in this debug output that you can hear me now, right?
Yeah, we can hear you.
Okay, cool. So you can see in this debug output that there are a lot of requests being spit out for /plays. That's the URL, and there's some data in there, which include the category and a day and a limit, and that's just stub data. And it's aware that there are lots of requests happening. So each of these plays viewer controls is requesting the exact same data. It's an identical control asking for the same data. And they're each firing off their own analytics API request. But because I put ApePI in the middle there, it's aware that each of those requests is redundant, and it just queues up promises to the API and makes one query for all of those. So in fact, as I was making all those changes, it was queuing up a few hundred API requests until the state stabilized. And then once the state stabilized, it made those queries en masse and return the results back. And you can see that I made 100 state changes, and it only fired off 6 requests at the end of the day for all those state changes. And you can check out the code for this project here. Sorry, let me turn off the endless thing there. All right, you can see
one quick question, Dan, if you want. So when you say state changes, like, is it the state on your kind of ape object, or do you mean like state changes, you're just changing this kind of observable object a million times, and that thing's state, you're waiting till it's kind of settled and then kind of updating the server with it?
Yeah, the first version of this I made was actually literally looking at the map, the can map, and waiting for that to stabilize. Then I decided that I wanted to build a more general purpose library that wasn't necessarily can specific. And so what it does is it uses a little finite state machine to observe when the API requests are stabilizing. So it's seeing that there are a lot of API requests happening, and then it can wait until that's stabilized. You can create as many of these ApePI objects as you want to kind of scope them. So you can say, I only want all my plays requests to be debounced. So you can create one instance for your plays and one instance for your categories model or whatever, and you can scope into the models if you want, or you can just have one global one that's managing all of the API requests. So It's doing that with its own internal state machine. Yeah. So that's basically ApePI, and it kind of, if you have any other ideas for how to solve that kind of problem, the worst scenario in this, where you have kind of tug of war with state, is where you have two controls that are changing one property back and forth, and they're literally saying, I want it to be true, and I want it to be false, and I want it to be true, and I want it to be false, and they just battle it out until end of time. So this gives you a potential mechanism to understand when the state has been sufficiently destabilized and when that tug of war is happening, and you can see that it's unstable and cut that off.
Yeah, it's awesome. It's something that we've dealt with like a few times. I don't know if you ever saw in JavaScript MVC there was a can model store back in the day. For one of our clients, we kind of built the same thing where, but it was more based around push state. So it didn't do any of the throttling or the debouncing, but it was able to. Well, it did know like if 2 requests were made. The same request was made. I don't know if you look in CanJS. There's can object, which allows you to compare objects and tell like what deltas are. So we've used that, and there's something that on our roadmap is can connect, where we really want to. You shouldn't. Inheritance is a poor choice for can model. Really, you should be able to define your observable, and then say, here's how I want to hook my, my observables up to some persistent storage, right? And you configure that persistent storage kind of independently, and then you configure your kind of observables. So we've had this idea for a while called can connect that we want so that you can kind of solve a lot of the same problems that you've solved, we've solved in the past, but do them in a way that like you can. Right now, there's only make find all. I don't know if you've ever seen that, where you can kind of create your own models that have their own custom behavior. That's a really terrible because then you have to inherit from it, and you can't do mix-ins and things like that. So yeah, it's kind of a problem that I've started seeing people try to do, and we kind of want to eventually get our heads around it and make something awesome.
Yeah, it'd be nice if some of the fixes for this were in the application layer and not in the API layer, because ApePI is not aware of your business logic. So it has to make all those API requests fire. It doesn't know what the origin of those requests are. So even though it can deduplicate those requests, it still doesn't know that this is an old request that has basically been deprecated by or superseded by a newer request, and so it doesn't have to make that request. It still fires off all of the requests, but at least it is able to deduplicate them and throttle them. You know what I'm saying?
Ours was much more based around like having kind of using push technology from the server than trying to solve the debounce. It was if you had, like, let's say I had a widget that requested a list and this requested the list again, it would, just like yours, find the original list. Does yours do that? It sounded like it kind of does. Or is it just during the two requests, it only sends out run request? Does it do the thing where, like, let's say I requested to-dos due today, and then 20 seconds later I requested to-dos due today? Does it know about that request, or does it then still just make another additional request?
You can set the debounce. It makes it an additional request. So it's designed to handle rapid fire behavior, pretty much. Yeah. So it's not a cache.
Yeah. So but that's the thing. There's all these cool things that you want to mix in with your AJAX requests, like a layer underneath, that everybody's kind of building themselves. And for us, I really want to look towards building kind of a flow where you can weave into custom behavior into the whole, like, okay, I'm making a request. Now the request has come back. And the whole, like, a big problem we struggle with is if you're doing kind of a more complex debouncing where, like, oh, I've already loaded this on the client, so I don't ever need to go back, especially since I'm getting state updates. If that gets torn down, you need to do that whole, like, tear down memory and things like that. But it'd be great to, I don't know, if you're interested, it'd be great to, or have you posted this? You made this
Yeah, it's public and it's up there.
Can you show us the website?
Yeah, so here's API. Oh, there we go. Yep, so I just pasted it into the chat, and here's the project. I already pasted the project ApePI CanJS presentation link to GitHub. So you can check out the code and see how you feel about it.
I'll quickly share my screen and show the website so people can see it. By the way, what is is it Onyx Rev?
Yes.
Onyx Rev, okay. And then ApePI.js.
Yeah.
Awesome.
Cool. Thank you very much, Dan, for the presentation. And we'll also tweet out the URLs to everything too, so people can reach. So moving on to the form section, I'm going to let Alexis take it for for like the next 7 minutes, and he's going to teach us about his show hide helper he's using with can.stache.
Yeah. So something we've come across in a few places, something we always come across is giant grids. Let me share my screen with you guys while I talk this out. And this is changed a little bit since we've kind of adopted Mustache as our go-to view engine. We've become trapped sometimes by the ease of the helpers that we provide in Mustache. So I'm going to go over one specifically, which is our if helper. Actually, before I show you this template, let me show you a little demo app here. So here we have a really simple grid. Let me make sure I'm on the right version of the template. Yep. So we have a really simple grid. I have 100 users here. I have their names, first name, last name, and their favorite color. And if you click on their name, it's going to do a show hide for their inputs. Really, really simple scenario. And then up the top, we have a show hide all. So we'll collapse all the rows and insert all the rows at once. Now with Mustache, with the introduction of Mustache, this is really, really easy to write into a template, loop through each person, and if some arbitrary Boolean is truthy or falsy, show or hide, insert or remove that those extra fields. Oh, it's their eye color. I'm sorry, I said favorite color. It was their eye color. Now here is the trap that we fall into. What if is doing is it's doing exactly that. It's inserting DOM elements into our page. So what I'm going to do is I'm going to hide all of these. I'm going to hit record in Chrome's little profiler here, and I'm going to show them all and stop recording. And this little guy, this is our click event. You can see the click event by itself took 80 milliseconds. Now this isn't a big deal. This is 100 rows. Most of our grid, if you have a large grid on a page, you probably don't have more than 100 rows. 100 is kind of a good threshold. But we only have 3 fields here. We have 2 inputs bound with can value, and we have one just a div with a background set to whatever this a particular user is. 80 milliseconds is still within the threshold of I'm not annoyed as a user. However, this scales in a terrible fashion. So I'm going to use another template here. I'm going to call it really slow. And really slow, all I did in this is I added a little bit more logic. I added 4 more fields, their height, the email, the company they work for, and their IP address, and a nested subtemplate, which just says foobar baz, just to showcase what happens if you add just a tiny little bit more logic into this guy. So I'm going to refresh my page here and clear this guy out, hide everything, and I'm going to hit record. I'm going to show them all one more time. Without even zooming over this, you can see this event is slightly larger. This one took 180 milliseconds. So we have more, I believe the first one was 70, I think. I've already forgotten. So we've more than doubled by just adding 4 more input fields. So with a particular project that I was working on, we had a how
many input fields were there before?
There was only 2. There's 4 input fields now and a subtemplate. So everything left of the color, right here, the color and left was before, and now we've added 4 more inputs, all with can values, and just this arbitrary string from a subtemplate. So this is a very just to make a point kind of template. If you can imagine a more complex grid, you probably have logic in your subtemplate as well. This is going to grow significantly. So, and this is a different approach. If we had a control as opposed to a component, then we would already know, hey, just show and hide the elements. You don't need to remove and insert them from the DOM. So the concept is very straightforward. However, actually putting in the code with the Mustache engine is not necessarily as straightforward. So I wrote a helper. I'm going to call this fast.stache. This is the same thing as slow.stache. Instead of if, I'm saying hide. If this is true, then this will be hidden. And that's all I'm doing. I'm going to show you what this code looks like here in a second. But first, let's take a look at how fast this loads in comparison. Let me refresh my page here, clear this all out, hide. I'm going to start recording, do the same thing, show them all. And you have to look for it, but you can spot it right there. So what initially was 70 milliseconds on our first slow template is down to 30. Or, excuse me, I'm sorry, 3 milliseconds, and then a little bit of rendering because we're just applying a style. But the rendering is going to happen anyways. So we're down to 3 or 4 milliseconds. On a large grid, this is much, much more performant. You're not adding and inserting a ton of elements at the same time. But because we're keeping things in the page and we're not using what we typically would do in a helper is reevaluate options.fn every single time or options.inverse. We need to be a little bit clever about this. Oops, that's the final version. Let me show you the version before that. So here's our helper here. You don't need to see all this other stuff, our initialization code. What we're doing in this helper is we're taking our truthy value, our truthy compute, and we're going to, let me minimize, let's focus on this guy first, var nodes. I'm using a little bit of an internal API. There is a better way to write this, so let me elaborate what this does in English versus getting hung up on the syntax. What we're doing is we're basically inserting a middleman in between the rendered DOM nodes and us having a hook into when this compute changes. So what we're going to do is we're going to take our current, this is just our placeholder for what the helper is, so it's this little guy, and everything inside of it will be options.fn or inverse. In our case, we're only using options.fn because you're not going to reevaluate, so you can't do something like that. So we're going to evaluate options.fn once, replace those nodes with something we want, and keep a hook to it. So we're going to have nodes here, and then whenever nodes change, so whenever our compute changes, we're going to invoke some kind of action with this node list. In our case, we're going to show and hide. This is just jQuery show and hide. If the compute is truthy, hide it. If it's falsy, show it. And then we're manually binding our compute. This is the middleman right here, line 41. We're replacing our node list with something that we want to listen to, and whenever the compute changes, we're going to keep reinvoking this function. This is the function that gets reinvoked. Line 49 is just the initialization. The first time you come through the helper, go ahead and invoke it immediately. And this third argument, this function here, is just the teardown for when we're recreating a node list. By just taking a different approach in our helper, you get a huge boost in performance if you're doing any kind of large grid management with collapsing or inserting and removing elements in large quantities. You get a lot more performance out of this.
So just to recap real quick, Alexis,
Sure.
Your original version of this was like using a normal mustache helper to just redraw, like it would recreate the elements every time like the collapsed property was changing?
Yes, exactly.
This new helper, what it does is it'll actually render the elements, but it will set their display to none, and then you're just changing kind of displayed to, you're just setting the display to block or whatever, just showing them with jQuery or hiding them with jQuery when the collapse changes, and you're getting a huge performance benefit because instead of recreating elements and then removing them from the page each time, you're just changing their display property to none or probably to empty or block or something like that.
That's exactly right. That's exactly what's going on here. Conceptually, it's really simple just to say, oh, $div show or hide. But with the node list and a mustache template, this part gets a little bit more complex. This was an early draft. Eventually, I did get to a point where I wanted the inverse of this hide. I wanted to say if it's falsy, hide it instead of if it's truthy, hide it. So there's a better way to do this.
Hey, Alexis, I
Yes.
think David asked a while ago, but to blow up your browser size, but
Oh,
I think
I'm
it's
sorry.
too late. Yeah.
I wasn't sure if you meant, yeah, sorry about that. This is all, I'll link this all in the chat. You can download this whole little demo app. You can look at the metrics yourself. It's all on GitHub, so I can post that here in a second. There's a better way to write this. I wrote a conditional place method, which will take any callback. So you can write any helper in this same kind of fashion. You can have your own hook into when some compute changes. In this case, it's just a simple, if you pass in a single compute and then execute some callback, I called it conditional replace. Based on this compute, we're going to execute this callback. That way I can do show or hide, which is the inverse. Full disclosure, this does not take into account of dynamically adding elements within the helper. So there's an even better way to write this. I just haven't gotten there yet. But yeah, this is basically it. Just a little, I guess, caution. There's been a few apps now, or a few instances where I've seen just an overuse of some of the simpler aspects of Mustache. Yeah, that's pretty much all I got. Let me link this for you guys.
Thank you very much, Alexis. And so yeah, we've got a few minutes left for Mihael. You can go ahead and tell us about your can form plugin.
Yes, so last week I'm working on a form component. I think this is like 5th or 6th time I wrote something that should manage forms, and I think I got it right. So let me show you a bit, and some code, some API, and some demos. So why do we need can form or something like that? So validations and error reporting is always a pain. You always have to handle it. It's not straightforward. It results with similar code being rewritten every time you need to handle a form, and particularly painful is a situation where you have to handle nested object structures. So can form, what it does is it allows you to still use can value. So it's two-way binding is great. Let's just keep using it. It behaves like the can component. It does some unholy stuff, though with it, but you can see it in the code later. One interesting thing is that it allows composable or nestable forms. So you can nest your forms one inside another, and it will handle the error reporting and everything correctly. It allows you to create validations on the form. I think this is a bit superior than having validations on the model, because validations are then bound to a context where you change the data. So you can have same model edited in multiple instances, and you don't want the same validations to be run every time, maybe. And it has really simple error reporting and tracking. So let me show you a simple API. So it behaves like a form, like a component. It has extend function. You can set the tag, template, and additionally you can set validate object. It comes with its own validation engine that knows how to handle nested objects and has some other sweet stuff. So it will create a simple form component. You still use can value here, and you get errors helper that will show you errors for attribute that you want to listen to. So this is straightforward. This is very simple simple example. Nothing fun to see here. But let's extend this form with an array of social network accounts. Let's say that we want to enable on the user to have multiple social network accounts, and we want to make sure that every social network account has a username and network property set. So this syntax here, it's inspired by stuff produced by can_map when it changes, when triggers change on objects. So instead of using index of the array, you just put here a star, and it will. This says validate username property for every element in social networks array. So it's really simple to validate nested objects. And here we have an example of nested form. So inside the simple form, there is a form. This is a default component that comes with a can form helper that just has a content element inside and no validation or anything. So you can just use it for cases like this. You pass it a map that you want to make it a context, and here this is path hinting. So if it cannot deduce what is the current path of the form object based on the map property, you can set its path, and it will use this to know what errors to show for your form elements. Let's say it like that. So this is live bound. If you change the position of the element in the can list, it will update everything correctly and track the errors correctly. But instead of using form form, you can create social network forms. So create a simple form that also has its own validation, its own context, its own view, and then you can just include it here as a component. So this basically allows you to reuse components in various contexts. It can be nested, or it can be a main form, and everything will work correctly. All errors will be correctly registered, and paths will be correctly tracked. So I have some demos here. Also, you can listen to the form state, so you can know when form is clean. Clean is when you create a form, it's in a clean state. If you submit it and there is no, it's invalid, and you can enter the data and it will go to clean. This makes it easy to listen to these changes from an outer component and know when you have to replace the form component with some else or some other view. So this is a simple component from the first example. This is a bit more interesting. So here it has a username, it has phone numbers, and it has social networks. If you press submit, so it validates username, it can be empty, but it will also validate the length of the phone numbers array. So you can have validations on arrays too. And when we add phone numbers, the validation will pass. And here is another interesting case. Here we have validation of simple values, so you can validate each item in an array of strings or numbers. So this is how you set the validation. So just instead of using a property, at the end you just use the star, and it will know to call validation on the whole object. And finally, the mega form, that's really cool. So this is something that you could see in some kind of CMS where you can add various elements. So let's say each of these has its own validation. Let's say something this will remove. You can drag and drop, which will change the indices in the array, but it will keep everything correct. So this form is also pretty simple. Each element I showed you there has its own little component with its own validations, and the scope of the article form component is really simple. You just add elements to the map.parts array, and here we are having some dynamic component rendering. Just creates template and it renders it inside of a helper. And when so this using jQuery UI drag and drop. When you stop the sorting, it will just replace everything in the parts array and update the indices. So this is all for me. Are there any questions?
Fantastic work, Mihael. It's really cool.
Thanks.
The one question. So is it possible to change it so you don't have to define those form components? Could you just use like validates presence of as an attribute?
Yeah, I was thinking about it. That could be added for some simpler cases, but if you have some more elaborate validations, I would still leave a possibility on the component. But it's not a problem to add support helpers, because forms, when they are nested, they know how to register on the top context, how to add validations. So
Yeah.
only the top form is basically stuff. Every other form is passive until it's in the main scope.
Yeah, I think it would just be really cool for especially beginners or simple forms to be able to write an attribute and have it work. The other thing, so you showed one example where you had like index embedded in a mustache template as part of the path attribute.
Yes.
Are you binding to the attributes event?
Yes. Yes.
Wow.
Yeah, it's abusing a lot of CanJS internals, but
no, that's actually what it's there for, right? It's like you could be listening to
it's the computer that's holding the path and recalculates everything.
Yeah, that's cool. So the okay, so you said the state changes you can listen to.
Yes.
Is there basically like a form map in there when you say you listen to it, or is it like producing like an event on the DOM?
No, you can pass the compute in the scope. Show it here. So just a second. So here I have state defined as a can compute, and I just paste it into as an attribute, and it will use that to inform you of the state changes.
So I'm definitely not a usability expert at all, but there's always that like case where you don't want to allow the person to even set a value. I think most forms aren't like that, where you just can put the value and then it'll give you a warning. But there are occasionally some forms where like you can't even set it to a incorrect state, like a number input or something like that.
Yeah.
Does this support that at all? Can it get in front of?
It doesn't care. It's something that you would handle on the can map level, and just listen to changes on can map that's in scope. So
yeah, the only other way would be to like have it so that on the element or the input element, it gets access to the value before can value gets access to the value, so it can like remove it.
Yeah, I tried to make it so it's a really thin layer around stuff that CanJS already supports. So it doesn't change the way you build your stuff. It just supports some additional like validations and error reporting, which is tricky.
What about also the worst type of validations, which are like okay, if you've got these two checkboxes, then you can check this. But if you've got only one, then you can't check it. Where like you have cross-state. I don't know what the name.
The validator supports validation of a whole object. You can say just use star, and it will validate the whole object, and you just have to return an object with the keys of the invalid elements. So yeah, it's possible.
Cool. Very cool.
Awesome.
That's all I have.
Yeah. Okay.
Well, awesome, guys. I think this is probably our best Hangout yet. They just keep getting better every week. Huge thank you, Dan, for coming on board and joining us Batovians and presenting what you're doing.
Dan, you're a rock star, right? You still you're in a band, right?
I've transitioned to opera, so I'm like post rock star now.
Very cool.
And then, so we'll be posting this to YouTube, just like we do every week. If you want to see some of ours from the previous weeks, you can just go to YouTube and pull them up. And other than that, please subscribe to our email list, follow our calendar, and or follow us on Google Plus or Twitter, so you can make sure to join these every week, because they're getting better and better. So, awesome! Thanks again to everybody, Alexis, Mihael, and Justin. And see you guys next week.
See you guys.
Bye.
Bye.
See ya.